class 8th, rational numbers. Okay, in this chapter we have representation of rational numbers on the number line. How to represent rational numbers on the number line. So before going to this topic, so we have some important ideas about rational numbers. Okay, what is that is rational numbers are infinite. We know that rational numbers are infinite, but in between any two rational numbers, for example 2 is there and 3 is there. 2 and 3 are natural numbers, whole numbers, integers as well as rational numbers. In between these two rational numbers, there is no natural number, there is no whole number, there is no integer, but there are infinite rational numbers. How many? For example 2.1, 2.11, 2.111 or 2.01, 2.01 or 2.99, 2.90, 2.91, 2.911, 2.920, 2.921, okay, 2.921. So like this you have so many. There will be infinite rational numbers between any two rational numbers. This concept we have to understand. Infinite rational numbers. We also know from the geometry, in between any 2 points there exist infinite points. There exist infinite points. That point is called as, okay, every point is denoted by one rational number. Denoted by one rational number. Every point is denoted by one rational number. Say suppose here 0 is there. This side are positive, this is right side, this is positive, and this is left of 0, that is negative. You have infinite rational numbers on this line. In between every point, in between every 2 points, there will be infinite points. You take very near the points, still there will be infinite points. You take 2.11, also you take 2.111, there will be infinite points. Simply you understand 2.1 and 2.2. In between this also there will be infinite rational numbers. So rational numbers are very thickly populated. What do you say? That is called density. So we say that is density, that means the density property of rational numbers. We say density property of rational number. What is density property means? In between every two rational numbers there exist infinite rational numbers. That property is called as density property of rational numbers. Okay, if the rational numbers are given simply, for example 2 by 3 and 5 by 3, 2 by 3 and 5 by 3. In between what do you have? 3 by 3, 4 by 3. But do you have only 2? No, there will be infinite. But simply we can say 3 by 3 and 4 by 3 are there in between the two rational numbers. But how to represent these on the number line? For example, 5 by 3 or 5 by 8. Say suppose 5 by 8 is one number and 7 by 8 is another number. These numbers should be represented on the number line. Okay, so this is the number line. On this number line, these are positive numbers. These positive numbers will be right of 0. 5 by 8 and 7 by 8. 5 by 8 where numerator is less than the denominator. Here also numerator is less than the denominator. That means that its value is less than 1. So less than 1 means you take up to here, this is 1 consider. This is 0, this is 1. This is divided into how many equal parts? 8 parts. Carefully you have to listen. 8 parts. So in that 8 parts, see there, first let me make it half. Okay, this is 4 part, this is 4 part. Make it half, make it half. Again make it half, make it half, make it half, make it half. That means there are 8 parts. Now this is 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, and this is 8 by 8. 8 by 8 is equal to how much? 1. So So now your 5 by 8 which is required, where it is? This one, round it off, and 7 by 8, here it is. So we have represented the two rational numbers on the number line. Like that, any number is given that can be expressed on the or represented on the number line. What do you have? Tell me, what are you doing? Suppose it is given as 1, 2 by 3. 1, 2 by 3 is a rational number. Okay? 3, 4 by 5 is a rational number. These two rational numbers should be represented on the number line. So now take a number line. After taking this number line, we can suppose if the numbers are very distant or so much difference is there between the numbers, then we can go one number on the number line, another number on the another number line. We take two different number lines. Here it is 1, 2 by 3 means it is clearly, it lies between 1 and 2. 1, 2 by 3. And this one 3, 4 by 5. 3, 4 by 5 means it comes after 3. Okay. So let's take this one is in a different parts I have to do. This one will be different parts I have to do. So therefore I take this one is on different number line. This one will be on the different number line. So let me take it here 0, and here it is 1. Here it is 2 suppose. Now according to the given number we have to plan it how to represent. Now this is 1, 2 by 3. 2 by 3 means after 1 remaining space. See there? This is 1. This is 2. This in between 1 and 2 remaining 1. So always we get 1 unit only. That 1 unit should be divided into 3 equal parts. So that means this one 1 to 2, this distance you have to divide into 3 equal parts. When you divide into 3 equal parts, so each part is called 1/3. Each part is called 1/3. So therefore this is 1, after this 1, 1 by 3, and this value will be 1, 2 by 3. This is 1, 3 by 3. That nothing but 2. So now what we want? 1, 2 by 3. 1, 2 by 3 is here. This is 1, 2 by 3. Like that we can identify every rational number on the number line. Okay? Every rational number can be expressed on the number line by using this concept. Now we have to express this 3, 4 by 5. 3, 4 by 5 means we take another number line. Take another number line, consider it is 0, consider it is 1 and 2 and 3. Suppose. This is 1, 2, 3. What do you want? 3, 4 by 5. After 3. So extend the number line. Extend the number line, and this is, let's say this is 4. Now 3, 4 by 5 means after 3 whatever the unit comes, that unit should be divided into 5 equal parts, and that fourth part we want. 5 equal parts means, let's say 1, 2, 3, 4 and 5. See there? 1 part, 2 parts, 3 parts, 4 parts, 5 parts. So it can be 3, 1 by 5. This is 3, 2 by 5. This will be 3, 3 by 5. This will be 3, 4 by 5. This is 3, 5 by 5. So this is the number which we want. So like that, any number is given. After that, whatever comes to the next unit, you divide into whichever equal parts required. That is how we can represent the numbers, rational numbers on the number line. So this is very, very important one. Okay. So for 8th class, this is there actually representing number on the number line, natural numbers, whole numbers, integers also we have seen in the lower classes. Okay. In the 8th class we have rational numbers. In the higher classes, if you go to 9th class, they will ask you represent root 3 on the number line or root 2 on the number line. That means real numbers they will ask. Okay. So this is what you have to learn here. Okay, na? So for more interesting videos or mathematical problems related, okay, so all of you please subscribe to VY Maths. Okay, I will give you solutions for any class or any problem. Okay, you can ask, even in the comments you can ask for whichever you want. Okay, so please subscribe for this VY Maths channel.